Hi everybody, my name is Taylor Richardson and today we are going to go over the Module 5 written exam. So we're going to go ahead and start with number 1, and the question says, write these decimals as fractions in the lowest terms and determine the prime factorization of the denominator in each case. So this problem requires a couple of steps and I have them written out for us and we're just going to go through them. So we're going to look at the decimals 0.225 and 0.036. And looking at these decimals, we know that they have digits in the thousandths place. And because of this, we can go ahead and put, for part A, the 225 over 1,000, and for part B, 036 over 1,000. And at this point, it's okay to go ahead and get rid of that 0. So we can just have 36 over 1,000 and 225 over 1,000. So now we're in nice pretty fractions and we don't have the decimals to look at anymore. And the next thing we need to do is find the greatest common divisor in order to find the lowest terms for these fractions. And so the greatest common divisor for 225 over 1,000 is 40. This means that 225 over 1,000 is equal to 9 over 40. And then the other one, part B, 36 over 1,000 is equal to 9 over 250. And so to look at these even further, we're going to determine the prime factorization for these fractions. And so we're going to move to the next page. And I have these written out nicely. We can see in part A, we have 9 over 40. And in order to find the prime factorization of that, we're going to break down the 40 to find the prime numbers that we can multiply together to get 40. And so 40 can be broken up into 4 times 10. And then the 4 is obviously broken up into 2 times 2. And 10 can be broken down into 2 times 5. And so this means that the prime factorization of 9 over 40 is 2 to the third times 5. And then for part B, we have 9 over 250, and we're going to do the same thing. We are going to break down the 250 here. And 250 can be broken down into 10 times 25. And then we're going to easily break that down. 10 breaks down into 2 times 5. And 25 can be broken down into 5 times 5. And so that means that the prime factorization for 9 over 250 is 5 to the third times 2. And so now we'll move on to question 2. And this one says, suppose that the variables x and y are related by each of the formulas shown below. Create a graph for each formula and make up a reason for the shape of the graph. And so the first formula we were given is y equals x over 2. And so the formula I came up with, or the reason for the formula I came up with, it says every week when I get paid, I put $2 of my paycheck in a savings jar. And the slope of this graph is 1/2, meaning that it moves up 2 and to the right 1 as the line moves. And then part B, we are going to, there's part B. We have the formula y equals negative x over 2. And so I came up with the reason by working out daily and eating healthy, Jenny hopes to lose 2 pounds each week. And so we can see this represented by the graph, and the slope of the graph is minus 1/2, negative 1/2, meaning that it moves down 1 and to the right 2 as the line moves. And that represents losing 2 pounds each week. And then part C, the equation we're given is y equals 10x. And the reason I came up with is that Sally is making cookies for her church, and she goes to a big church, so she needs to bake 10 times the number of cookies that the recipe calls for in order to have enough cookies for all her people at her church. And so the slope of this graph is 10 over 1, meaning that it moves up the y-axis 10 points and to the right 1 as the line moves. And now we'll go back and do part D. And the equation we're given is y equals x squared. And the reason I came up with, it says, Julie is making a blanket and she wants it to be twice as big as it already is. The slope here is a positive up 1 over 1 curve. that we can see shown on the graph here. And so now we'll move on to number 3. This one's always fun, involving the shapes. The question says, what percent and fraction of each of these figures is shaded? And so the first one we can easily figure out. We have a square, and we see it is divided into 4 sections, and each one of those obviously is going to represent 1/4 of the square. And so this one section over here, half of it is shaded. And so we need to know what half of a fourth is. Well, half of a fourth is an eighth. We all know that. So that means that an eighth of this square is shaded, and 1/8 is equal to 12.5%. So that means 12.5% of this square is shaded. And so similarly, we're going to look at this bigger square. It's divided into 9 smaller squares, but we are going to divide that even further, and we are going to do like the very first box is, we're going to divide each smaller square into 2 triangles. And so when we divide all of those squares into these triangles, we can see that 7 of the 18 triangles that we now have are shaded. That means 7/18 of this square is shaded, and 7/18 is equal to 38.9%. And so moving on, here is part C. For that one, here's the circle, and we know this as the yin-yang sign. And you can see I have it shaded here because my printer was broken, so I couldn't print it out nicely. And so the reason I came up with, or rather, we have this circle here, and although it's not a straight line dividing this circle in half, we know that the yin-yang sign is divided in half. It's half dark, half white. So since we have that symbol here, or something similar to that symbol, we know that half of this circle is shaded, or 50%. And so moving on to number 4, if the area of a yellow hexagon is the whole, then the remaining pattern blocks have areas that are approximately 16.67%, 19.2%, 33.3%, 38.5%, and 50%. Show how the pattern blocks correspond to the given percent of the hexagon. And so we're going to go ahead and dive in. We know that when we see a hexagon, we know that 2 trapezoids can fit inside that hexagon. One goes on top and one goes on bottom. And so we know right off the bat that the 50% is corresponding with the trapezoid. And then we'll move on to the rhombus, and it's going to be the bigger rhombus that we have. And we can see that 2 of the rhombuses, or rhombi, can fit into the hexagon easily, but we're still left over with some space, a little bit on each side of where the rhombi are. And so in order to fill this space, what we're going to do is we're going to take one of the rhombi and we're going to divide it in half. And so by doing this, we're going to put 1/2 on each side of each of these little spaces that we have left. And that's going to make up our whole third rhombus that's going to fit in there. And so that means that we can fit 3 rhombi in there. And so that means the rhombus represents or corresponds to 33.3% of the hexagon. And then we'll look at the triangle, and I have some rather poorly drawn triangles here, I'm sorry. But if we do start drawing triangles in the hexagon, we can see that 6 triangles can easily fit in there, 3 on top and 3 on bottom. And so we can easily figure this out. If we divide 100 by 6, we get 16.67%, and that is what each little triangle represents in the hexagon. And then we'll look at the square. A square can fit into a trapezoid about 2.5 times. It's kind of odd and probably uncomfortable fitting for them, you know, it doesn't all the way fit in there on the outside. But when you multiply 100 times 2.6, or 1 over 2.6, you get 38.5%, and that's what each square represents of the hexagon. And so that is what I have for Module 5's exam. So I hope you enjoyed, and we'll see you next time. Thank you.